Good morning friends. Today we are going to discuss about the daily problem of Geeks Symmetric Tree. Given a root of a binary tree, check whether it is symmetric, which means that whether the tree is a mirror image of itself. A binary tree is symmetric if the left subtree is a mirror reflection of the right subtree, which means that like if I draw a line over here exactly bisecting vertically from the root, then you check you keep a mirror over here and try to see whether the same tree is reflecting this side. So 2 is reflecting this side and 4 is reflecting this side and 3 is reflecting this side. So this is symmetric tree, which is correct. Now we will solve this question step by step. So I need to have 2 pointers of root. I'll be having a helper function f. Let us name clearly so that it will be easy for understanding. I'll be having a helper function which returns a boolean type. This helper function takes 2 inputs, that is here basically I am comparing 2 trees which are symmetric. If 2 trees which are symmetric, then they will be 2 trees which are symmetric over which are symmetric, and there will be mirror image of itself. Here I will be explaining it why. So I will be taking 2 nodes. I will be removing this extra bracket. See, if my root 1 is null pointer and root 2 is also null pointer, at any point of stage if my root 1 and root 2 are null pointer, then I need to return true because both are same. If only root 1 is null pointer, then return false. If only root 2 is null pointer, which means that root 1, if I have root 1 as null pointer, then root 2 is not null pointer, and if I have root 2 as null pointer, then root 1 is not null pointer, because it's an OR condition, hence return false. If both of them are null pointer, now we can clearly say that both of the root 1 and root 2 are not null pointer, so there is some values existing. If root 1 dot data is same as root 2 dot data, then I need to go inside because those are same, correct. If it is not the case, then there is no then we need to return false. If root 1 dot data and root 2 dot data are correct, then I need to check their children. How should I check the children? I should go for the root 1 dot left and I should check for the root 2 dot right. Similarly, and this condition should be valid and also this condition should be valid. Root 1 dot right and root 2 dot left, both the conditions should be valid, and if both the conditions are true, then only I'll return true, otherwise I'll go with false. Let's try running it. Here we are ensuring that left child, okay, my bad, we are we have used helper function, we are named it as helper. I was used to use the helper function with name f, so it's a muscle memory. Let's try submitting it. The complexity will be the number of nodes in the tree. Every time we are checking at each level what are the number of nodes, and the space complexity will be the stack of the tree, I mean height of the tree, because once after reaching a level, and if you are able to, if after reaching the leaf state, if you are checking that, we will just remove that state and we will go back to the previous state. So we are removing that particular memory from the stack. So height of the tree will be the space. At max, height of the tree only will be the space. Yeah, it is accepted. So if you find my content interesting, please do like, share and subscribe, and you can also find the playlist of DSA in my in this channel itself. And if you have any questions regarding this, if you have any questions regarding this problem, you can comment it down. I'll reply on it, and I'll also keep the cards over the top so that you can find it easy to navigate to the other POTD problems. Thank you.